Hey guys, this is Ms. Moore. Today's video, we're going to be talking about groups and periods and the differences between groups and periods and some of the tricks that help me remember the difference between groups and periods. So first I want to start off with groups. Groups are these columns that go up and down. Sometimes they're called groups and sometimes they're called columns. But in the scientific world, we know them as groups. They are grouped this way because all elements within each of these up and down columns have similar properties, similar chemical properties. Most importantly, each of these have the same number of valence electrons. So we'll get into more of that in just a second. Not only do they have the same number of valence electrons, they also have a similar reactivity. So all of the elements in this group will react similar as all of the other elements in that group. So what we're going to do is I'm going to write here at the top some of the important things. So groups, stuff you want to remember, have similar chemical properties. They also have the same number of valence electrons and similar reactivity. All right, so those are the three main things that you need to remember or know about groups. We're going to switch it up for just a second. Now we're going to talk about periods. So periods are over here on the side. And I like to do like this. We're going to draw. They go from side to side. And we're going to write this on over here. So periods indicate the number of shells or orbitals that go around each of the elements, and every element within that period or row has the same number of shells. So what that means is in period 1, we have hydrogen and you have helium. It goes all the way across. If we were to draw out hydrogen, it would only have one orbital or one energy shell. When we draw out helium, it only has one orbital or one shell. So if we come down here to period 2, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. All of these have 2 energy shells. So they have electrons that go onto 2 energy shells. And this is true all the way down. So period 3, we need 3 shells. Period 4 needs 4 shells. Period 5 needs 5 shells. All the way down to period 7, I would have to draw 7 energy shells to make some francium or radium. Those are the only things that have in common, that these periods have in common, are the number of energy shells. And that's periods. So the way that I remember periods, or I like to, is whenever I write a sentence, let's say, Miss Moore is the best. I need a period at the end of my sentence. Sentences go from side to side. Therefore, I need a period just like these rows go from side to side, and that's why we call them periods. All right, so let me erase some of this and we can go back to groups. So we remember periods, they go side to side. Groups go up and down in columns. Let me erase this. And we're going to remember our groups here. All right, so the next important thing about groups, we're going to go backwards. Groups are numbered at the top. So this would be group 1, group 2. We're going to skip these over here in the middle. I'll talk about that in just a second. We have group 13, group 14, 15, 16, 17, and group 18. We do not mess with these over here in the middle. These are transition metals, and we will get back to those later on whenever you get into high school. The valence electron rule does not apply to all of them. They kind of do their own thing, but you don't need to know that for 8th grade science. But what we will focus on are these nice little A numbers at the top. These are important. I always tell my students, your periodic table is like a cheat sheet. You just got to know what the codes are. So the numbers at the top are the group number. The A number indicates the number of valence electrons that that group has. So group 1 has 1 valence electron. Group 2 has 2A, therefore it has 2 valence electrons. If we go over here to group 13, guess what? It's got 3 valence electrons right here at this A number. Group 14 has 4 valence electrons. Group 15 has 5 valence electrons. Group 16 has 6 valence electrons. 17 has 7, and 18 has 8. These are extremely important numbers when we're talking about similar chemical properties, talking about groups, and talking about valence electrons. It all comes down to reactivity. Reactivity determines how an element responds to other elements and how they bond together. So let me clear some of this out and make some space. I'm going to erase here. So we're talking about reactivity and groups, and it's extremely important to understand how we find our reactivity. So not only are they numbered, right? Group 1 has 1A, group 2, 2 valence electrons, group 13, 3 valence electrons. I tell my students that we have 1 valence electron, so this group 1 is highly reactive. All elements want 8 electrons is our magic number. Every single outer shell wants 8 electrons. So group 1 only has 1 valence electron on its outermost shell. It's got to find 7 more to be able to fill that shell and make 8. So they're highly reactive. Group 2, they have 2 valence electrons. They are reactive. They don't have as much work to do. They're still reactive, but they don't have as much work to do. They only need 6 more valence electrons to make a full shell of 8 electrons. Same goes for groups 13. They're reactive. 3 valence electron, only need 5 more to make 8. Group 14, they're at 4. They're halfway to 8, so they're reactive. Group 15, they've got 5 valence electrons. They only need 3 more to make a full shell. And then group 16 has 6 valence electrons. They need 2 more to make a full shell. But then you get down here to group 17, and they've got 7. They've got 1, 2, 3, 4, 5, 6, 7. 7 valence electrons, and they got to get to 8. So they're kind of freaking out. They can only bond with certain elements, only ones that have 1 electron on its outermost shell. So they're very picky. So group 17 with 7 valence electrons is also highly reactive. My kids, we label it HR. HR for highly reactive. So they know that they put highly reactive or HR above groups 1A and group 17 with 7 valence electrons. There is one group that is super happy. It's group 18. Group 18 was lucky enough to already have 8 valence electrons, with the exception of helium because it has 2, but I can only fit 2 electrons on my first shell. Therefore, it's already full. But the rule applies to neon, argon, krypton. They all have 8 valence electrons all the way down. So their shell is full. They don't bond with other things. So they are non-reactive. This is the only group out of all of these that is non-reactive. So we always label it NR for non-reactive. So you've got groups 1 and group 7. They are highly reactive. And then the rest of the groups, group 2, group 13, 14, 15, 16, they are all just reactive. And then you've got group 18 down here that is non-reactive. So another way that we like to label these in my class is we will go through and we kind of give them some faces. Let me erase some of this. It's kind of getting a little messy for my taste. So another way that we will do this whenever we're going through and we are labeling our periodic table and getting our cheat sheet ready is we will go through and we always make an angry face for group 1 and for group 17. We have an angry face because they are highly reactive. And then for our others, we just do a regular face for reactive, regular reactive. And then for group 18, that's just always super happy. They're full. We do a super happy non-reactive face. So we've got non-reactive, highly reactive, 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 and then highly reactive. All right, so those are the breakdowns of groups and periods. Remember, groups go up and down in columns. And periods go side to side. All right,